Hello and welcome to Bonhill Geography. Today we'll be looking at hydrographs. A hydrograph is a graphical representation of the flow rate, otherwise known as discharge in meters cubed per second, of a river or stream over time. It's an essential tool in hydrology, in other words, monitoring how rivers essentially work, for understanding how water flow responds to precipitation events or rainfall events. The rising limb. Now, the rising limb represents the increase in river discharge following a precipitation event. It indicates how quickly the river responds to rainfall. If the rising limb, as we can see on the diagram here, is very steep, this suggests rapid surface runoff and potentially leading to a flood. If it's very gentle, then it means that the water is getting to the river very slowly from the river, meaning it's less likely to flood. Discharge. This is the highest point on the hydrograph, as we can see at the top. This indicates the maximum amount of flow rate normally in discharge in meters cubed per second. Now, this helps in assessing the severity of a flood event. If it's really high, it's just more likely to flood. Next, we have the falling limb, otherwise known sometimes as the recession limb. You've got to be careful with AQA language. So the falling limb or recession limb shows the decline in discharge after the peak. Reflects how quickly the river returns to its base flow or normal flow. A gentle slope indicates prolonged runoff, while a steep slope suggests quick drainage. Next, sometimes we can normally see if we have a long lag time leading up to a flood event, which we'll talk about more in a moment. If it's a really long lag time, we'd expect to see a really long, essentially lag time after this, where it takes a long time for the water to drain away. Now, as previously mentioned, we have the base flow. This is the normal day-to-day flow of the river sustained by groundwater, sometimes by the water table. Provides a baseline for understanding the river's response to precipitation events. Now, we'd expect to see the base flow essentially lining up with the start of our diagram and the end of our diagram. That shows the normal flow rate of the river. Next, we have the lag time. This is one of the most important key terms to remember for your river's tests. Now, lag time is the interval or time between the peak of the rainfall event, shown by our bar, and the peak of the discharge event. You can see that by the dotted line at the top of the diagram. Now, it helps in flood forecasting and management. Short lag times indicate a higher risk of flash flooding, hence why we call the diagram that we see here a flashy hydrograph. If the lag time is very long, we'd expect to see a lower peak discharge, meaning that there's a long lag time and less risk of flooding. Next, we have storm flow. Storm flow is known as the direct runoff, or the proportion of the hydrograph that represents the immediate response to rainfall. Sometimes this can be defined as essentially surface runoff. It's crucial for understanding the impact storm events on river discharge. So, it's anything above the base flow. Lastly, we have bankful discharge. As indicated by the diagram, this is when the river level is high enough that it goes over the banks. Now, I've put a kind of temporary line on here, but the bankful discharge varies massively from river to river. For example, if the river's been altered by human activity and embankments have been put in place, the peak discharge or the bankful discharge will be much higher, meaning that it can hold more water before a flood. If there's been no alteration to the river, and the river is quite shallow, the bankful discharge will be significantly lower and the flood could be even worse. Now let's talk about a flashy hydrograph. A flashy hydrograph has a steep rising limb, indicating that discharge increases rapidly after a precipitation event. It reaches a high peak discharge very quickly and has a short lag time between the peak of rainfall and the peak discharge. The recession limb is also steep, showing that the discharge decreases quickly after the rainfall event. Now, flashy hydrographs are often caused by intense rainfall, urbanisation with impervious surfaces or impermeable surfaces, steep slopes in which surface runoff occurs, and areas with low amounts of vegetation. Now, these factors mean there's lots of surface runoff and quick increases in discharge. Remember, surface runoff is the fastest flow to the river. Let's now compare this to a subdued hydrograph. A subdued hydrograph has a gentle rising limb. This indicates that a discharge increases slowly after the precipitation event. Now, it reaches a lower peak discharge and has a more gradual and longer lag time between peak rainfall and peak discharge. The recession limb is also quite gentle, showing that discharge is going to slowly decrease after the flooding event. Now what's important to remember here is this is probably somewhere that's not been affected by human activity. Let's explain this a bit further. Hydrographs are often caused by moderate amounts of rainfall. Natural landscapes with permeable soils or permeable rock and dense vegetation. These are going to increase interception and infiltration, so it means as a result we see lower amounts of surface runoff and more through flow, which is significantly slower than anything to do with surface runoff. This contributes significantly towards the longer lag time. So to summarise, a flashy hydrograph indicates a rapid and intense response to rainfall, often leading to higher flood risks with a short lag time, while a subdued hydrograph shows a slower and more gradual response with a long lag time that is typically associated with lower flood risks. Can you see an example on the video on the left that shows our flashy response with high flood risk, and the video on our right which has had no human alteration. Now here are two example questions you could get asked about hydrographs. Number 1, explain why hydrographs can help to reduce flood risk. And number 2, differences in the shape of flood hydrographs are caused by both human and physical factors. Do you agree using the figure in your answer? Now this question was from the 2018 exam paper about Ostwick and Clapham Beck. Let's explain through these answers. Hydrographs help to display the peak discharge, which is often the highest flow rate during a precipitation event. By identifying peak discharge, hydrographs allow hydrologists to assess the severity of potential flooding. A high peak discharge indicates a greater volume of water flowing through the river, which can lead to flooding if the river banks are unable to contain it. This information is crucial for designing flood defences and implementing early warning systems to protect communities. They also show lag time between rainfall and peak discharge. Hydrographs illustrate the lag time, which is the interval between the peak of the rainfall event and peak discharge. Understanding the lag time helps in predicting how quickly a river will respond to rainfall. A short lag time suggests a rapid response, increasing the risk of flash flooding. This knowledge enables authorities to issue timely flood warnings and take preventative measures, including evacuations, temporary flood barriers, to mitigate the impact on the affected areas. Here is a screenshot of the rivers rubrics I've made for my Year 11 students, and we can see the difference between the flashy and the subdued hydrograph. So the flashy hydrograph has a short lag time and a high discharge. This means it's more likely to flood, 1 mark. Human factors that could have affected this include increasing concrete. This is an impermeable surfaces that would lead to increases in surface runoff. This would lead to a short lag time as it flows into the river quickly. We've used the figure to explain our answer, but it's also asking us about physical factors. So however, it may also be surrounded by steep slopes. This is a physical factor. Steep slopes speed up the water and can prevent infiltration. As a reminder, that's water soaking in. So there's more surface runoff, again leading to a decreased or shorter lag time. So far, we'd have about 4 marks, but we should talk about the other figure as well. So the subdued hydrograph probably has little human influence, gentle slopes and vegetation. This would explain the long lag time and low peak discharge. Small conclusion for do you agree? In conclusion, people cause higher flood risk than physical factors. Thank you for watching Bonhill Geography. I'll catch you in the next video.